Welcome back to Champions, to the object-oriented programming class of Python, right? Hope you're doing good and enjoying all the lectures. And today's topic is going to be instance classes and instance methods, static methods, and class methods. But before I start, because I know that online trainings are not very good at teaching theoreticals. That's why I first show practicals and then I take out my time for theoreticals, and those theoreticals are very important when it comes to object oriented programming. So we will be taking a look at some of the theoreticals today, and along with some more valid practicals, including instance method, class methods, and static methods in Python. So let's get quickly started, right? Because we just started with object oriented programming with Python, right? So it's my duty to tell you what is coming and what is the agenda, right? What are the objectives, right? So to start with the objectives of object-oriented programming, it's very important, very important. So the objectives are what are classes? We have already seen, right? Why don't I keep it just like this? Okay, what are classes, right? Objectives are classes and objects, right? We have seen classes and objects, but I'll define them so that even if at the time of interview you're able to qualify, and at the time of examinations you're easily able to pass examinations whenever asked, right? So we have, this is the major concept. We have encapsulation of data and methods, all right? And we have some important topics like constructors, right? And we have constructors and destructors, right? We have operator overloading, or you call it as we have inheritance. So we will be checking whatever we this is going to be a sort of checklist that we'll check while completing, right? For example, this is complete, we'll check it out, and then this completes, we check it out, right? So this is going to be just a stack with a checklist, whatever you may say. So inheritance in a real world. Oops, right? And we are going to have operator overloading is there. So there is object-oriented programming in Python and some other programming languages. There is a difference. It differs from other programming languages, like we don't have private here, right? So we are going to learn that slowly, right? And just to be very precise, so we will start with these things, and these are the keystones, or we can say they are the the major points for learning object-oriented programming in Python, right? So first of all, classes and objects. So I gave you a definition of class. I gave you the definition of object. What is a class? Class, I said, it is a template, right? Class is a template, right? What sort of template? A user-defined, right? So that's it for the class. And what does it take? What can we have inside a class? Right? So we can say user-defined, or we can say user-defined prototype. Right? We can say user-defined prototype for an object that defines every single a set of attributes. So you have to take a note of whatever I am writing. I'm not writing for me. I know what a class is. I'm writing for you. So please take a note of them. So a class is a template, a user-defined prototype for an object that defines a set of attributes, right? Or we can say attributes that that characterize any object of the class, or we can say any object of the class. Now what are the attributes? So now if you ask the question, what are the attributes, right? I said a class is a template. We know that we create a template. A class can have objects of, or a class can have methods, class can have variables, class can have constructor. We can call many different things in a class. Class is a collection of we can say properties and methods, right, and attributes. And now, but what I have written here, a user-defined prototype for an object that defines a set of attributes in a character, that defines set of attributes that characterize any object of the class. Now what are the attributes of the class? Right, so attributes are data members, right? So they are the data members. So we can say class variable. So that's why I thought of defining it, because if I don't define it, you'll not be able to understand what are the attributes. So they are class variables. That's what our topic for today is: class variables and instance variables, right? So now what is an object, right? So I'll write it down here. Object is an instance of the class. Now just to define it more practically, right, because whatever I teach you theoretically, so that has to follow some practicals, right, or something in practicality. So this is how we define class. We have said class is a template, a user defined prototype for an object that defines a set of attributes. So we have to define class and attributes, right? For example, if I define this class, right, and I say class test, right, and now this class test can have a constructor. For example, I have a constructor, so I'll say define, right, and I'll pass the self here. Okay, why do we require the self? Because the self is basically a keyword that is required. That's basically, this is a necessity in Python, that you need to pass the object name. So self means the class name itself, which is test. So this is how it works in Python, right? All right. So now we have to define some variables. For example, if I define a value, or we can say we have to define some attributes. For example, if I define an attribute here, so I will say user name is equivalent to this, right? And now if I go here, I will say self dot username is equivalent to this. And now if I run it, now you can see that you don't have any program, the file, right, unless you make an object of the class. Now what is this? This is an attribute. What is this? This is an attribute. Now the attributes can differ. That's what we said. They can be class variables and we can have instance variables, right? And then object. What is the object? It's an instance of the class. So how do you make an instance of the class? So I'll say t is equivalent to test. Now what is the t? T is an object. Why? Because t is referring and creating an instance of the class, right? So I'll just go ahead and see that we don't have any error. But now we have two username. One username is here, another username is here. What is this username known as, and what is this? That is the second topic, and that's what we have to discuss today. Not because we have written it here, because that was already decided what the topic for today is going to be, right? But yeah, now as long as class is concerned, is your class a template? Yeah. Does it contain attributes? Yeah, it contains attributes. It can contain methods. It can contain different things that we will access with the help of an object name. Now what is this called as? You can call this object, or you can call this object creation, or you can call this as an instance of the class, right? So you can either say that this is an instance of the class, or you can say it's an object of the class, which t is an object for test. What is test? Test is the name of the class. Now why do we pass parentheses here? As I said, every time you call the class, you basically call the zero parameter constructor, right? For example, if the constructor accepts an argument, for example num, right? So that's what I have already told you. It's going to throw an error that the constructor is accepting one argument and you have not passed it here. So that's why I'll have to pass the argument in order to validate the constructor. Now you can see there is no error. Alright, so this is the call to the constructor, and basically object It is the constructor who allocates memory for the object of the class. Okay, so as long as this definition is concerned, this is already clear. Object is an instance of the class. Now, what is encapsulation and what are of encapsulation of data? What is encapsulation of data and what is encapsulation of methods, right? Constructors we have already known, destructors are still to know, operator overloading is still to come, and inheritance is still to come. This is all what we have in object-oriented in Python. I know that unlike other programming languages, we have many different things, like we have like constructor overloading is there, function overloading is there, and abstraction even is there. So those things are not available in Python. In Python, object-oriented is basically limited to these things, and I'll tell you why is it limited to these things. It's very beautiful, and that's what the beauty of Python is, because all the classes are basically here related to each other. You'll come to know, right, in next or maybe 2 or 3 classes, right? Because we have to understand scopes. What is the scope, right? And every single thing, right? So before we start learning the scope, we have to clear class variable and instance variable, and also the static variable. That's what the class for today is going to be, so that we'll check it out that this thing is complete. Then we'll take this, I'll say this thing is complete, this thing is complete. So everything is complete, let's say about 20-30%, but not completely. But yeah, I'll have to show you separately, right? So I'll take one by one and show you separately. Class is understood, object is understood. Now class variables and instance variables are yet to be understood. So that is what is going to come next, and that's why I know that the previous class of accessors and mutators is not understood by each and every one of you easily, and you're not going to understand unless you practice it a lot, right? With practice you will understand more better things, because the length and the duration of the class is going to eventually increase, right? The length of the source code that you write, or the amount of source code that you may usually write, has to be, it is going to increase eventually, right? Day in and day out, right? So that's why you need to work a bit more harder now, right? So that is basically that's the need of an hour now, because you cannot even skip away, or you cannot just get away with the class just by attending the class, right? So please practice more, and let's get started with class variables, instance variables, and different sort of things, right? Okay, let's get started. All right. Okay, I have already spoken a bit about instance variables and class variables, but I haven't spoken about annotations using the same. But today we are going to learn it with annotations, right? So because without annotations you're not going to understand it. So let's quickly go and get started. For example, we have this class test. We'll keep it class test, and this class test has let's say about school, and let's call the school as NIIT. All right, and for example this is going to accept for example marks. So I will say M1, M2 and M3, for example. Now this constructor is going to accept M1, M2 and M3, 3 parameters, right? And what we can say, self.m1 is equivalent to m1. Now what is this self.m1? What are we trying to do here? We are just started to declare it. We're just declaring it, right? So I'm not doing it with the spider this time, because of making you different things, or making you understand different things in a different manner. So I'm not going to write long code today, because I'll have to explain each and every one line by line. So I'll try and explain line by line. I'll try and go topic by topic. So that's why I have to delete many different things. I'll have to write and delete, so that it goes through your brain and you're able to understand. What is self.mi? Right, so you are declaring a variable here, and whenever you call and make an object of this class, you have to pass m1, m2 and m3. So whatever you pass, m1 goes to this variable. So this is different. This is basically you're taking it from the parameter and you're dropping it to a new variable. So you're declaring a new attribute of a class, which is of course a variable here. All right, So then another self dot m2 is equivalent to m2, then self dot m3 is equivalent to m3, and then I can say self dot m. Okay, we have only 3, so we'll just close it down on 3. So I'm having this habit of terminating things. So you should not try and terminate things using anything, or you not anything, but only in Python. It is crime. It's basically carnage termination. Okay, fine. So for example, let us define a method which finds AVG. Let's say about. It's going to find an average. Now, why do you require self here? Now, I'll tell you this first of all. So this is the function which finds the average. For example, I have to return the average, or I have to return the average of all 3. Alright, so how do you return the average? Because I have to call this now self.m1. So if I call this m1, so it's going to throw an error. Now I have to call self.m1. So that is why this self has to be available in every single method of the class, right? Now you're calling self dot. Now what is self? Within this class there's m1. Now if this self is not available, you may not be able to use the self here. Alright, so that's the funda here. So I'll say m2 self dot m3, so you can easily do this. But yeah, since I am going to return an average of self dot m1 plus self dot m2 plus self dot m3, and since I have to return an average, I'll say divided by 3. So this is the function that is going to return average right here. Okay, and now I will say, I'll make a method right here. I will say define, right, and I will say define info, and I am not going to pass self here, but I am going to pass CLS something, right, anything, whatever. It's not going to accept self, it's going to accept any parameter, normal parameter right here. So I'll say return, right, CLS dot, so this is the class basically. So I will say, right, so I'm going to return CLS, or we can say, let's say test dot school. So this is going to accept test, right. So now all 3 methods, we have created this method, we have created this method, we have created this, and we have created this. So what will I do right here? I'll try and mark this as, let me first try and run it. Okay, let me try and run this so that, okay, T is equivalent to test. I have made an instance of the class. Now I'll take an instance of the class T and T, or let's say T1 and T2. We have 2 instances is equal to test. So that is the beauty of class, that we can have as many objects as we can, or we can create as many instances as we can. But we are going to get an error here by missing 3 required positional arguments, because of the constructor at the time of initialization is accepting 1, 2 and 3 arguments. So that means you have to pass 3 arguments. So I'll say 30, 40, and let's say 27. So I'm passing 3 arguments. So here I'll pass 89, 32 and 12, 2 arguments. So now when I call class, so it works absolutely fine. So I do not have any error in here. Now if I say t1 dot, or again say print, hey, I need to print t1 dot, right, so I can say I will get an average right here. Would you please show me an average? So I'll say okay, right. You can say now the average is 32.33. so you can say round, you can take a round of average, as you know how round works. Yeah, the round is 32. So this is an average of T1. So now can we take an average of T2? Right, so we can take an average of T2, which is going to be 44, right? And now which school has this average, right? So I will say, I'll just use here, I will say T2 dot school, right? Or I can say info. I want to get t2 dot info. So let me not pass anything. Now you can see that I have not passed any argument right here. Right, t2.info is giving me an IIT, right, and the average is 44, but because I have not passed any argument here, so this is basically going to be a method which is known as a class method. Now how do you decorate class method? How do you tell the Python interpreter? Python does not have compiler, as you know. Python has interpreter. Why? What is the difference? Because Python is not a programming language, it's a scripting language. Interpreter reads it through like this. Interpreter will read it line by line. First line, second line, third line, fourth line, right? So that's what you already know. And you're telling the interpreter that, hey, this is the class method. Now, how do you define this to be a class method? So you'll use annotation at the rate of class method, right? Now, how do you make a class how do you make a class method? Just by decorating the method by at the rate of class method annotations, right? So they're known as Python annotations. So now if I run it, now you can see that we're getting it in a single line. We're not creating two instances right here. We are getting, now if I just delete it, so this is going to be just it doesn't matter what we are getting in a single line or double line, has nothing to do with class method. But yeah, I'll tell you like this, what is a class method? Class method, because they deal with class variables. What is a class method? Any method, right? So I'll write it down here. Please and please and please and please note them down. So I'll just document it. It's called documentation. I'm commenting it. Comment is basically ignored by the interpreter. Whatever I write here within the comments, within this or within this, these things, it's going to be completely ignored by the Python interpreter, right? Okay, so now what is class method, right? Class method, because it deals, what does it deal with? Please answer me. Because it deals with class variable. So now this is school here, right? It is defined not using self here, right? Does it have cells? No, because the scope of this school variable is accessible throughout the class, right? You can access it from anywhere in the class. For example, I have to pass self to basically access this. So this is not a class variable, right? I'll make you understand. For example, if I go to this average function and I'll say hello is equal to 10, right? So now average function has a variable which is hello and it has value 10. So now can I say, for example, I want to access this hello variable, right? So can I say this? Can I access it? No, I will not be able to access it. For example, if I say t1 dot, now you can see, hit control plus space bar, average is there, school is clearly available here, m1 is available, m2 is available, m3 and average. Hello is not available. Why? Because the scope of this variable will not be available throughout the class. You are declaring this variable inside the function average. That means the scope of this variable hello will not be available outside the average function. I cannot access this variable here in info, or I cannot access this hello variable here in the constructor. So just to make a variable global means which can be accessed from anywhere in the class, right? We call that as class variable, right? Why? Right? You tell me, why is it class variable, right? Okay. Accessible from, or we can say accessible throughout. So it is going to be accessible You have to note them down. Note these important topics down. It's very important. Okay. All right. A class variable is accessible throughout, but what is that throughout? So it is accessible throughout the class. Now, if you go out for an interview tomorrow and they ask you what is in class variable, you'll say a variable which is accessible throughout the class and a variable which is declared without using the self keyword, and the variable which is directly inside a class, neither inside a method and nor inside a variable. Repeat and pause and see what I said has to be noted down. Note it down. All right. So after noting it down, what is a class method? Class method is any method that deals only with class variables. So after decorating this method with class method annotations, we are making sure that this class is going to deal only and only and only and only with class variables, right? So now if I say return, and let's say about return self dot, so you'll say there's nothing is available. If I say self dot m1, so clearly see you'll get an error, right? Why? Because you are not passing self. It's a class method. Even if you pass self, even if you pass self, right, you can still see that it's getting an error because it is a class method. You have decorated it with an annotation class method. That means now it cannot handle any variable which is not a class variable. So that means a class method cannot handle, right, or cannot take care of non-class variables. So it will only handle class variables. So you can clearly see here class variables. Okay. All right. And now in order to make it, you have to decorate it. Now, what is a class method? I repeat, what is a class variable? A variable which is global and is accessible throughout the class without even using, and is declared without using a self keyword. Right. So it cannot be declared inside any method. It has to be declared directly inside a class. Okay, what is a class method? A method which is decorated with an annotation. Everything that starts with @ is called as an annotation. A method which is decorated with class method annotation and it deals only with class variables is known as a class method. Now I suppose both the things are understood, right? And now, for example, I will create define, right? So let's call this new info. I'm creating another method which is called as new info. Now I'll say, hey, I need to print this is a student class. Alright, so I'm going to print this. So now what if I want to print this class without creating an object of the class? Are you trying to get me? I say I want to access the class method, which is this method, without creating an object of the class. For example, let me delete all. Now I want to access this without creating an object of the class. So I will say, okay, what's the name of the class? Test. So I will say test dot, I can say test dot new info. Can I access it? Now you can say this is a student class. Now you are able to access it without creating an instance of the class. So now that is what is known as static method, and we decorate this method using static method annotation. So the moment I decorate it, now you can see, right, so it's called as a static method, right? So test.new info. If it accepts self, so it is not going to be a static, right? It's not going to be a static method because it accepts self. Alright, so that means you have to pass this self. Even if I delete this now, if it accepts self, what do you pass? You have to pass the object of the class as in self. So a static method is not going to accept self. Or even if it accepts any parameter, let's say about it accepts name. right? So now you have to pass name. I'll say, yeah, I will pass name Fahim. So I'll pass my name Fahim. Okay, so I'll say welcome, right? And I will use this and I'll say welcome and I'll use name and let me format it. Let's see how it will. Welcome Fahim, this is a student class. You can see no instance of the class is made. I am not making any instance of the class. I'm calling it statically. Right now, if I show you a few more things regarding this static right here. All right. Okay. All right. So this is how a static method works. Now you can even take it from as an input. You can say a single line statement. Enter your name, right? So now I can go ahead and say enter your name. All right, I will say Fahim. So now you're getting enter your name Fahim. So you're getting welcome Fahim, this is a student class. You're getting welcome Fahim, this is a student class. Now what is a static method? A method, right, whose instance is not created, right? Or you can access a method that you are accessing without creating an instance of the class. It saves memory. For example, if I call this method twice, not a new instance is made, but old instance is used. I'm calling it twice now. Now let us see what happens. Enter your name. So I'll say Fahim. So I'm getting it. Welcome Fahim, this is a student class. Enter your name, Khan. So welcome Khan, this is a student class. So now here you are not making two instances. Static method will make sure that the memory is allocated only once now. And you are accessing the static method with the same instance that you have created earlier. So this is this instance, right? So if I say give me and let's say about t is equivalent to, so I'll say t, I'll say print ID of t. So let's print ID of t and see what are we getting. So let me say FHIM. So you can see this is the ID, this is the memory allocation of the method, static method. So now if I use it twice, okay, so let me use it twice now. All right. So I'll say enter your name. So I'll say Fahim. Alright, welcome Fahim, this is the student class and this is the memory that you are referring to. So I'll say Fahim. Now you can see both are referring to the same location. That means static instances, the static methods which are decorated, static methods are the methods which are decorated with @ of static method annotations, and they do not use the object name. That means it's not necessary to create the object of the class or the instance of the class to create the static method. The static methods can directly be accessed with the class name without creating an instance of the class. Right? And the second thing, that they use the old instance rather than the new instance. For example, I'll show you. Now you can see it here. The instance, they're referring to the same memory allocation of the RAM. Now for example, if it's not a static method, right, so let's say about it is going to accept let's say about it's going to accept self and it's going to accept name as well. So I have to create two instances then, right? I'll tell you how. I will say t is equivalent to test because it's a non-static method now. So I will say t is equivalent to test and then I say print. Okay, so I can say print print t dot, and now you have to call new info. Right, so now you can call this method here, which is new info, and you have to pass your name. So for example, I pass my name as Fahim. Now you can see, okay, because the test takes few arguments, so I have to pass M1, M2 and MT. So let me pass 10, 20 and 30. Now you can see welcome Fahim, this is a student class and none. What is none? Why are we getting none? Right? I don't know. Okay, why are we even printing it? I don't know why I'm printing it. Okay, fine. Welcome Fahim, this is the student class. So now what you are getting? You have created an object of the class. Now you have to call it again. For example, I say T2 is equivalent to test 30, 40, 50. So you have to create a new instance of the class here. You're creating a new instance of the class. I can say T dot new info, right, and I will say F, or we can say KHAN or Fahim, right? So these are called as two instances. Now this is non-static method. You're creating two instances. You're getting this. Now if I say print ID of, right, this, and I'll say print ID. Are they pointing to the same memory allocation? So I'll have to see. Okay, one print. You have to get ID of this. So it's absolutely fine. So we don't have any problem here. Why are we getting an error here? I don't know. Okay, so let me do this. Okay, let me say ID is equivalent to ID of T dot new. So then I'll print the same ID. Is it possible? Yeah, it is possible. I'll use the same here, T2. So now I'll have to say T2, right? So ID 2, and I'll say ID 2. So I just print it out. It's not callable. What is not callable? I don't know. We just saw that. Yeah, you can see that we are getting this here, and now we have creating T2 is equal to test, and say ID2 is equal to ID of T2 new info Fahim, and print ID2. So we should not get any error. What? I know. ID of, I can use the same ID right here. So just int object is not callable. Now how was it callable earlier and it's not callable now? Okay, let me delete it and see the memory allocation of this first. Yeah, you can see that it is 140706393173216 that we are having ID 2. So now I'll say ID. Now if I get an ID, right, so I don't, okay, it's a built-in function. Yeah, sorry. So let me replace it with ID now. It's still pointing to the same direction because of the same name, right? Because it has a same name. If I change the same name, the object name remains same. Which is why it is in Python that it is basically Python is very memory efficient. It doesn't matter. It doesn't matter whether you're using static or you're using non-static methods. It is still going to point towards the same instance. But yeah, now you can see that if I have to call this info, right, or if I have to call this new info, I had created this, right? What if I don't want to create this object? I want to call it directly. So I will say, hey, wait a second. What you need to do is mention it as @static. Use the static method annotation and just go ahead and call. And now you don't have to accept self. Now what you do, call the method, or we can say call the class directly with the class name. What's the name of the class? Test, and the dot I will call new info, and I'll pass my name, right? Or you can say an IIT. You can pass any name, right? And you can say I want to print it, but since we are printing it here, so we don't need to print here. Now you're getting welcome and IT. This is a student class. Now you can see it's very easy to call static methods, right? without creating an instance or an object of the class. Now the question is, when do you use static methods? Static methods are only used for the data, right? We will use static methods for the data that we want to be available throughout the application, right? I want, for example, I have a database connection. Now this is a method that returns me a database connection. The database is used for login, it's used for register, it's used everywhere. So I would really want my database connection to be static, because it has to be used many times. So I don't want to create more memory, right? So I'll create it as static, and that too without creating an instance. I don't have to create an instance of the class, right? Static method. Now definition, I'll just revise. What is a class variable? A class variable is a variable which is declared only inside a class, right? And which is global, right? And can be accessed from anywhere. And class variables are declared without using self keyword. What is a class method? Class method is a method that is decorated with class method annotations, and it deals only with class variables like school. What is a static method? A static method is a method that can be accessed without creating an instance of the class, and a static method is basically used for any function that is meant to be reused. I say we use static method for any function or method that is meant to be reused throughout the application. It saves memory, it saves code, right? Now this is the static method. Now can we create, okay, now these things are done. Now what are these known as? These are known as instance variables, right? So this is not a class variable. These are called as instance variables. Now what is this function known as? Right, which is this is self, so it is instance method. I told you any function without a class is called as a function, and a function and a class is not called as a function, it's called as a method, right? Now why is it an instance method? Because it works with an object, right? Okay, so you can say it's an instance method because it requires an instance, because you cannot access this AVG without creating an instance of the class. Now for example, I will say test.avg, right? So can I access it just like static? No, right? You cannot access it. Even if you pass any arguments, yet it's going to throw an error, right? You can still say, right? Because if you have to create an instance to access this method. What is an instance method? A method that cannot be created without creating an instance of the class. So that means first you have to create an instance of the class, then and only then you'll be able to access. For example, I will say test. I say t is equal to new test, and it accepts something, so I'll pass, and I'll say t.avg, and then if I run, it is going to be absolutely fine. 10, 20, 30 is equal to new. What is new? Sorry, I'm just using Java here. Okay, welcome and I did. So now we are able to access this AVG, but we cannot access this AVG without creating an instance. That is why it's an instance method. Why is it an instance method? Because we have first created an instance, which is t is an object name of test. What is t? Object for test class, and or we can say t is an instance of test class, and then we say t.average. We access this AVG method with this object name, which is t, right? That is why it's an instance method. Why? Because you have to create an instance of a class in order to access the instance method. Same is with instance variable, which cannot be accessed without creating an instance of the class, right? Class methods can also not require instance, right? You can even call class methods. You can see this, for example, if I say test.info, right? And now because it is a class method, right, so it is going to return info. So I will directly say print test.info. It's not an instance method, so you're getting NIID, right? Because it has school, right? So that class method can also be accessed without creating an instance of the class, and static method can also be accessed without creating an instance of the class. But just because of memory management and because of we can say using the old instance rather than creating the new instance. Both can be used, both are very useful. A static method and a class method, both can be used, and both can be used as a pro, right? I suppose you have got so far. And let me go back to the previous class. And what we learned in the previous class was very simple exercise and mutators. We learned the model to design. And believe me, I challenge you, now onwards, I write it down, now onwards, right? You are going to learn something you will not find anywhere across the world. You will not find it anywhere in books. You're not going to find anywhere on YouTube. I challenge you to show me a single video of the login panel that I showed you in the previous lecture. We developed the login panel. Now we developed the login panel using XSRs and mutators, wherein we had model 2 design being applied, right? MVC pattern being applied, and that's an open challenge. Show me a single video of MVC pattern, the same video which I showed you, the same way which I showed you in the previous lecture of XSRs and mutators. Alright, so that is why the classes now onwards are going to be very important, because no book, no YouTube, no video, no tuition is going to show you the things that we are going to show you in a professional studies, right? So if you are having problems with annotations, or if you are having problems with exercises and mutators, please tell me. I will not hesitate in recording a new lecture for that, right? But yeah, as long as exercises and mutators are concerned, we just made, it was quite simple. What we did, we created a business logic, we created a model, and we created a view. Alright, so I suppose I still want you guys to check that video 2 to 3 times before I basically make a new video for you. Right, and that exercise and mutators video is pretty important before I jump into something advanced which is related to database, because now onwards we are going to connect database. Same login we are going to use, right? So we are going to use the same login panel to get connected with the database. What is the timing? So okay, we are running out of the time today. All right, so I advise you to at least learn this completely, right? So now shall I erase this? Classes and objects is done. Is it done? Right. Instance variables, static variables, and we can see class variables is also done. That's why I wrote this is what your class can have. Your class can have attributes, which are variables. Variables can be class variables, instance variables, or static variables. Your class can have methods. The methods can be instance variables, class variables, or static variables. Alright, then you access those objects of the class, or the methods of the class, or you access those attributes of the class by creating an object of the class. What is object? It's an instance of the class. I suppose this part is done now. Encapsulation, constructor is also done, destructor is not done, operator overloading is not done, inheritance in the real world is not done. So this is what our object-oriented programming is dependent on. Object, basically we deal in real world things, right? Hey dog, you have a property, you can bark. Now I create a method, bark, the dog starts barking, because it already has a property, right? So that's why we first create a property, then we create a function, just like in the previous class, right? And you are going to understand slowly and steadily, and I shall continue my theoreticals alongside the practicals with every now and again, right? And tomorrow's topic will be inheritance, and it is going to be a class inside class, and we are going to learn, yeah, that's going to be tomorrow's function, and along with the destructor, right? And then we'll take operator overloading a day after tomorrow. I just want to wind it up so quickly. Maybe in 5 to 6 classes intermediate is going to be winded up, and we are going to start with something very fresh and something very exciting. So I'm very excited for that. I shall be waiting for your response. Yeah, in case, don't move forward in case you're having problem. Buzz me, PM me, message me, right? Stop me in case if you're having problems anywhere, right? In the class, in today's class or in the previous class, because this is from the previous class where we started actually learning something realistic and something very real, right? So if you have problem, don't close down your eyes and go ahead. You cannot do that, right? You have to at least do justice to your studies, right? Wait a second, stop your video, pause your video. If you're not understanding anything, message me, I shall reply. Even if I have to make a small video clip to make you guys understand, I'll make a small video clip to make you understand. Then only when you have understood everything, please and please forward your studies with that. So I wish you all the best. Please continue with the previous lecture. After watching, even after watching this lecture, I want you to go back to the previous lecture of exercise and mutators, right? Because that covers everything. That covers encapsulation, abstract, that covers each and everything, right? Watch it again and then watch it this video again, right? And see you tomorrow with a new video of inheritance, inshallah. I wish you all the best. Bye bye. Take care of yourself.